In 1889, the Eiffel Tower became the tallest structure on Earth. But height wasn't its only challenge. Behind its elegant iron lattice lies one of the most unusual elevator systems ever conceived. Because the tower doesn't go straight up, moving thousands of visitors each day demanded a complete rethink of elevator design. Engineers answered with a series of bold experimental machines, some so unconventional they could only exist in the 1890s. Without these, the tower's upper levels would have been nearly impossible to reach. But the innovation doesn't end there. The tower is packed with hidden engineering solutions, systems designed to solve problems no structure had faced before. To understand how they work, we've spent hundreds of hours rebuilding the Eiffel Tower piece by piece, uncovering how its design has evolved for more than a century. Rising from the heart of Paris, France, the Eiffel Tower was built as the centerpiece of the 1889 World's Fair to celebrate the 100th anniversary of the French Revolution. The tower stands between the Seine River to the northwest and the Champ de Mars, a vast public green space stretching out to the southeast. The tower takes its name from engineer Gustave Eiffel, whose company was responsible for both its design and construction. Under his direction, the project moved at an astonishing pace. From start to finish, the Eiffel Tower was completed in just 2 years and 2 months. As it rose, it shattered records. During construction, it overtook the Washington Monument, then the tallest structure in the world at 169 meters, to become the tallest human-made structure ever built, reaching an unprecedented height of 312 meters and breaking both the 200-meter and 300-meter height barriers. It held that title for 41 years, until New York City's Chrysler Building surpassed it in 1930 at 319 meters. In 1957, a broadcasting antenna was added to its summit, making it taller than the Chrysler Building, though by then, the Empire State Building had already claimed the record. Today, the Eiffel Tower's impact is measured not just in meters, but in visitors. It is the most visited paid monument in the world, welcoming around 7 million people every year, all drawn to a structure that redefined what was possible when it first pierced the Paris skyline. What stands in Paris today, however, is not quite the tower that opened in 1889, and that becomes clear as you start to peel back the layers. For more than a century, the Eiffel Tower has been constantly renovated, refined, and adapted to handle an ever-growing number of visitors. At its core, the Eiffel Tower is a wrought-iron lattice structure shaped like a massive pylon. 4 pillars spread wide at the base and gradually converge as they rise, joined together by girders at regular intervals. This open-frame design isn't just iconic, it was carefully optimized for wind resistance. The lattice allows air to pass through the structure, reducing pressure and helping the tower withstand powerful gusts. Every piece of metal in the tower is held together with rivets, not welds, which was standard practice at the time of construction. In total, 2.5 million rivets hold the structure together. The tower has a square base, measuring 125 meters on each side, and today it stands 330 meters tall. In 2022, a digital radio antenna was installed, bringing the tower to its current height. The tower's color has also evolved over time. Today, it appears in a yellow-brown shade, but that wasn't always the case. When it opened in 1889, the Eiffel Tower was painted reddish-brown. Over the years, it was repainted multiple times, shifting from red to yellow, and then through several different shades of brown before settling on its current tone. Every evening, the tower comes alive with light. It's illuminated nightly, and at the start of every hour, it sparkles for 5 minutes, a familiar ritual that has become synonymous with Paris itself. Beneath it all, the foundation is just as carefully engineered. Each of the tower's 4 pillars sits on 4 massive masonry blocks that extend about 7 meters below ground. The tops of these blocks are inclined to support the main girders of each pillar, and each block sits atop a large concrete footing beneath it. The Eiffel Tower has 3 public floors. The first floor sits at a height of 57 meters and is accessible by stairs or elevator, which we'll explore in detail later. This level contains 3 modern red buildings with glass facades on both sides, housing event spaces, a restaurant, shops, and an exhibition area. When the tower first opened, this level looked very different. It featured 4 wooden pavilions, each containing a restaurant that could seat 500 people. Over time, multiple pavilions have come and gone. Running along the outer edge of the first floor is a roofed sightseeing gallery that wraps around the structure, just a few steps below the main level. On the four sides of the tower, just below this gallery, are 72 engraved names. French scientists honored for their contributions, included as a tribute from Gustave Eiffel to the scientific world. At the center of the first floor is a large opening. Along its edge is a walkway with glass guardrails and glass flooring, offering a straight-down view to the ground below. To put the scale into perspective, the opening is large enough to fit the entire Statue of Liberty, and it still wouldn't reach the second floor, which stands at 115 meters. Like the first floor, the second floor is accessible by stairs or elevator, and it is split into two sightseeing levels. Above the upper level sits the Jules Verne restaurant, which opened in 1983. It's a gourmet restaurant with 2 Michelin stars and is accessed by a dedicated elevator from the ground. Reaching the third floor was anything but straightforward. Getting people there forced engineers into a solution that still shapes the tower today, an intermediate level between the second and third floors. Closed to the public and never intended for sightseeing, it played a critical role in the tower's original elevator system. It's details like this that reveal just how much is happening inside the Eiffel Tower, which inspired us to create this Eiffel Tower poster, mapping out its every detail. Grab yours through the link in the description. Every purchase directly supports the channel and the team behind it. We're also giving one away. For a chance to win one, like this video, subscribe, and comment below. What surprised you most about the Eiffel Tower? We'll announce the winner in the next video. And a quick shout out to our last giveaway winner. Congratulations! The third and top floor sits at 276 meters and is accessible only by elevator. The stairs here are reserved for emergency use only. The third floor is divided into 2 public levels. On the lower level, the elevators arrive at an outdoor observation gallery, with windows on all sides providing breathtaking panoramic views of Paris. 2 staircases lead up to the upper level, which is the highest public space on the tower. An open-air observation platform surrounds a central structure that houses a reconstructed portion of Gustave Eiffel's original office. This space was once part of a much larger apartment, which was gradually removed to make room for technical facilities. The original apartment included a living room, kitchen, offices, laboratories, and a bathroom, with the primary purpose of receiving distinguished guests and conducting scientific experiments. Above this are non-public levels that contain essential elevator machinery and communications equipment for the antennas overhead. Since the tower's completion in 1889, the top has changed significantly as antennas and broadcasting equipment were added, gradually increasing its height and altering its silhouette. Moving people through a structure that doesn't go straight up demanded solutions unlike anything used before. And over time, the Eiffel Tower's elevators evolved in remarkably different ways. Some systems were replaced entirely, while others, commissioned back in 1899, remain in operation today. Today, the Eiffel Tower operates 7 elevators, each adapted to the tower's unusual geometry and increasing visitor demands. Inside each of the tower's 4 inclined pillars is a unique elevator system that travels between the ground and the second floor. These elevators are neither traditional vertical lifts, nor funiculars or cable cars. Instead, they are custom-built systems designed specifically to follow the tower's sloping legs. The elevators travel along inclined tracks, set at 54 degrees up to the first floor, then steepening to 74 degrees up to the second floor. 3 of these elevators are used by visitors and are located in the north, east, and west pillars. Each system consists of 2 passenger cabins stacked vertically on a single carriage, which moves along rails inside the pillar, similar to a train car, but on a steep incline. As the angle of the track changes during the ascent, the cabins are kept perfectly level. Traction cables attached to either side of the carriage pull it upward. These cables pass over large pulleys at the second floor before descending back down to the drive systems located at the base of each pillar, systems we'll look at in detail shortly. The south pillar uses a slightly different arrangement. Here, 2 smaller single-car elevators are installed side by side. One elevator is reserved exclusively for guests of the Jules Verne restaurant on the second floor, while the other is a freight elevator used by Eiffel Tower staff. Between the second and third floors are two elevators, each consisting of two paired cars. When one car ascends, the other descends, counterbalancing each other during operation. When the tower first opened, 5 hydraulic elevators were placed into service, one in each of the 4 pillars and one operating between the second and third floors. These early elevators relied on 3 different systems, all supplied by different companies and powered by pressurized water. For the first 10 years, the power needed to run these elevators came from steam engines installed in a machine room beneath the south pillar. But what was actually happening inside this hidden machine room? We break it down in a separate video, available now exclusively to our YouTube and Patreon members. Placing a vertical elevator shaft anywhere within the open area beneath the first floor was aesthetically unthinkable, so engineers were forced to place elevators inside the tower's inclined legs, creating one of the greatest engineering challenges of the project. All pillar elevators followed the same fundamental idea still used today: 2 passenger cabins stacked vertically on a carriage traveling along inclined tracks. However, 2 very different systems were installed by 2 different companies. The elevators installed in the east and west pillars were supplied by the French company Rue Combaluzier et Le Pape. They could only reach the first floor and were highly unconventional even for their time. Instead of cables, the system relied on 2 endless chains made of rigid, articulated links. The passenger carriage was attached to these chains and was pushed from below, rather than pulled from above. At the base of each pillar, the chains were driven by 2 large-diameter sprockets, while idler sprockets on the first floor guided the chains back downward. These drive sprockets were powered by 2 large hydraulic cylinders, installed horizontally and parallel to each other at the base of the pillar. A separate set of smaller chains transmitted motion from the hydraulic cylinders to the drive sprockets. Pulleys mounted to the ends of the piston rods guided these chains. One end of each chain was fixed to the machine frame, while the free end passed beneath the cylinders and wrapped around smaller sprockets, which in turn rotated the main drive sprockets. As the piston rods extended, the free ends of the chains moved in the opposite direction, turning the sprockets and raising or lowering the passenger carriage. Despite its ingenuity, the system lacked speed and reliability and remained in service only until 1897. Next, the elevators in the north and south pillars were supplied by the American company Otis. These systems were cable-driven and powered by a single large inclined hydraulic cylinder. Rather than moving the passenger carriage directly, the piston rod drove a separate carriage fitted with counterweights and pulleys. This carriage traveled along an inclined track, positioned above and parallel to the lower section of the passenger carriage path. A second set of pulleys was fixed higher up inside the pillar. The cables moving the passenger carriage were threaded through both sets, forming an arrangement similar to a block and tackle system that multiplied its motion, allowing a short piston stroke to lift the carriage over a much greater distance. Today, the North Pillar elevator has been fully modernized. While the original hydraulic system has been replaced by an electric drive, the elevator still operates on the same basic principle, with passenger and counterweight carriages connected by cables running through pulleys. In the 1980s, the South Pillar was equipped with the 2 smaller single-car elevators seen today. Going back to the East and West Pillars, to replace the Rue system that was first put in place, elevators supplied by the French company Fives Lille were installed in 1899. These new elevators could reach the second floor, unlike their predecessors, and remarkably, they are still in service today. The system uses cables, driven by 2 large horizontal hydraulic cylinders, each 16 meters long, installed underground beneath each pillar. Each piston rod pushes a drive carriage that runs horizontally on tracks and carries multiple pulleys. A second set of pulleys is fixed at the rear end of each hydraulic cylinder. As with the North Pillar elevator, the cables moving the passenger carriage were threaded through both sets of pulleys, multiplying the motion. A 1-meter movement of the drive carriage results in an 8-meter movement of the passenger carriage. Until 1986, the hydraulic cylinders were driven by a system powered by 3 massive cylindrical weight accumulators. After modernization, high-pressure oil hydraulic motors replaced the original system, driving the carriage through a rack and pinion mechanism. 2 of the 3 historic accumulators now serve solely as counterweights. Today, a mannequin occupies the operator's former position beneath the lower cabin, demonstrating how the elevator was once manually controlled before full automation. Finally, the original vertical elevator between the second and third floors was supplied by the French company Edu. In 1889, no elevator could travel the full 160 meters between these levels in a single run. To solve this, engineers installed two 80-meter hydraulic cylinders at the second level, extending nearly halfway to the third floor. One elevator car sat atop these cylinders and traveled between the intermediate level and the third floor. Cables ran from the top of this car over pulleys at the third level and back down to a second car operating between the second floor and the intermediate level. The two cars acted as counterweights for each other, with each cabin traveling only half the total height. Passengers had to step off at the intermediate level, cross a short gangway, and transfer to the second car to continue upward. This system was later replaced to improve efficiency. Today's elevators between the second and third floors still use paired cars that counterbalance each other, but now each travels the full distance, driven by an electric motor installed at the third floor level. Today, the Eiffel Tower's elevators travel a combined 103,000 kilometers each year, or about 2.5 times around the world. When the Eiffel Tower was conceived for the 1889 World's Fair, it was never meant to be permanent. Built with a permit that lasted just 20 years, the plan was simple. After 2 decades, the tower would be dismantled and removed from the Paris skyline. Gustave Eiffel understood that the only way to save it was to prove its usefulness. Under his direction, the tower became a living laboratory. Scientists carried out meteorological and astronomical observations, physics experiments, and wind studies high above the city. But in the end, it was a new technology that truly secured the tower's future. Eiffel successfully reimagined the structure as a powerful platform for wireless transmission. By promoting it as an ideal support for radio antennas, the tower gained a vital scientific role that made demolition unthinkable. And its impact didn't stop at Paris. The Eiffel Tower inspired cities around the world to dream just as big. In London, plans were drawn up for a rival iron lattice tower, Watkins Tower, intended to surpass the Eiffel Tower in height. Construction began in 1892, but the project was never completed. More than a century later, the Eiffel Tower has far outlived its original purpose. What began as a temporary exhibition structure now stands as both a global symbol of Paris and a working piece of infrastructure, continuously adapted, continuously used, and still rising above the city more than 130 years after it was built. But there is another famous structure, one that has presided over a city for 2,000 years. For centuries, most people that stepped foot there didn't know what lurked beneath. But after hundreds of hours of research and modeling, we can now show you exactly what lies hidden within the Colosseum. Thanks for watching. Stay curious.